Okay, so we are going to go through this super quick. Okay, I have my Quizlet popped up because the kind of the cards that I made go right in line with like exactly what I'm like how I studied it. So I think it'll really help to kind of see like how the Quizlet is structured with that. Okay, so when we're talking about our immune system, we're talking about two things happening. You have your innate immunity, which is like a natural barrier and an inflammatory response. And then you have your adaptive immunity. And in this one, she just talked about the innate immunity, so that's kind of just it. Your first line of defense is also known as your natural barrier. So like right here, it's just your skin and your mucous membranes, so like your skin. The second line is the inflammation, and the third line is the adaptive, which is not in the slides. So the first line exists and is things like your tears and your skin, which has like a low temperature, so bacteria don't want to grow on it, and things like in the GI tract, like how much it proliferates. So like the sloughing off of cells in the GI tract, for example, like cells are constantly being regenerated and remade, so it's hard for anything to infect it when it's just now about to die. And then we get a new one, and then it's hard for that one to be infected because it's also just now about to die. And they're also highly interconnected junctions, so like they rarely have any gaps in them that anything can squeeze through. And then another thing with the skin is the skin is also known as an epithelial surface, and that's just because the epithelial cells are on the skin. So like when she asks what is like the cells involved in our first line of defense, it's epithelial cells. The epithelial cells secrete three things, and they really make or trap or do three things. They make peptides, which we're going to see in like our saliva. They secrete like sweat, which is like antibacterial, which is what she's kind of talking about right here. Like sebaceous glands in skin secrete antibacterial and antifungal acids. So like our sweat is naturally acidic. And then it also has lysozymes in it. So like a lysozyme, which is going to like attack bacteria like as like it gets in. So like if you think about our saliva or our sweat or our tears, anytime it comes in contact, because it has these fatty acids and these lactic acids, the lysozymes inside of it are going to attack, and our saliva, our tears, our sweat, it's literally antibacterial. So like if I don't want my, like I could literally clean it with, I could clean like a surface with it, and it would take some stuff off. Not like perfectly, but yeah. So going in depth on the peptides, the exact types of peptides. So like up here, it's like 2 peptides. There are 2, and there's defensins and collectins, and defensins defend. So like they're like the swords. So like they're stabbing things. So they disrupt bacterial membranes. And then they also are going to end up playing a role in the second and third lines of defenses. So like defensins are in our skin, inside our skin, but they don't just play a role in our skin. They're going to help activate our second and our third line of defense, which is not our skin. So the skin also has something called a collectin, which is a glycoprotein. So a defensin is a peptide, which means it's just a protein, whereas a collectin is a glycoprotein. So it has glucose on top of a protein. So it's a little bit more like advanced, you can think of it like. So like a defensin is just a sword. There's nothing pretty on the sword, whereas like it's a stick that you can poke things with. Whereas like a collectin is a stick with a flag at the end, which is kind of like exactly how it works. It's going to facilitate recognition of a microorganism. And so these are secreted by the lungs, and its literal job is just to basically be a flag. So at the end of our stick now, instead of just being a defensin and being able to poke things, we can wave the flag around and be like, hey, something's wrong here. And that's going to be a major role in protection. These ones are found in our respiratory tract. That is why they're secreted by the lungs. So glycoproteins, the glycoprotein collectin is found in our lungs, and they help stop respiratory tract infections by doing that flag waving. You also have like just chemicals. So like these are actual proteins, but do we have any actual chemicals on our skin too? Yeah. You actually have chemicals that are made by the bacteria that make up our skin. So like in Patho, in micro, he always talks about like, oh, what's the natural microbiota of our skin? Well, our first line of defense isn't just skin, it's also the bacteria that live there. And the bacteria that live there, like in the vagina, secrete an acid. That's a chemical. The intestines, they secrete alcohol. That's like acidic, so that things burn. And your skin also produces a toxin that can kill bad bacteria. So the good bacteria on our skin secrete chemicals like a toxin that kind of like are going to like kill the bad bacteria not on our skin. Okay, so yeah, that's pretty good. This is actually really, really easy and good to kind of look at and see. So innate immunity, the things we're born with. We're born with barriers. We're born with skin and mucus, obviously. And then we're also born with this inflammatory response, which is the next slide. The timing of the defense is always. We never not have skin. Like it's always there. It's very broad, right? So it doesn't really, there's no skin that only protects against pseudo. All skin protects against all bacteria. The cells are epithelial cells because the skin is also known as the epithelium. There's no memory, so there's no skin coming in contact with the bacteria and being like, well, now I'm going to be a callus because this bacteria I remember was bad last time. Like that's not happening. The peptides are 3, the defensins, the just pokers, the collectins, which are just the flag, and the toxins, which are just on our microbiota and they're just being secreted. And then the protection is anatomic barriers and so on and so on. Okay. So once we breach the natural barrier, so something stabbed me. Okay. I don't know why I'm talking so much about stabbing, but something stabbed me. Let's go down here. I'm going to get my first response, which is like my natural barrier, right? But when I'm stabbed, my first line of protection was breached. It didn't do what it was supposed to, right? Because our skin can't, fight against being stabbed. But so another second line of defense is going to come in. And the second line of defense, it's activated when the cells in the tissue are damaged. So when somebody stabs me, my cell and my tissue, aka my first line of defense, has been fucked. So now the second line of defense is going to come in. And it's going to be like, okay, let's do some shit, okay? And what it does is non-specific, very fast, and does not involve any memory. So there is no T or B cells in the second line of defense. And it's going to get more complicated. And just remember that if ever a T or a B cell or a lymphocyte, anything like that is mentioned, that's not our second line of defense. That is our third. Our second line is just inflammation. So if something is inflamed, you're going to get these cardinal signs, which is redness, heat, swelling, and pain. And you're also going to see one more where it's like the area that has that inflammation loses its function. So like later on, she's going to be like, hey, like obviously if my skin is stabbed, the area that's been stabbed, it loses its function. So can it now protect against like bacteria getting in? No, because the skin's not there anymore. It's been stabbed. So the first thing that happens in an inflammation is actually this slide first. And that's a little bit confusing because she put this slide. So biochemical mediators actually go to the site first. And these are histamines, bradykinins, leukotrienes, and prostaglandins. And what they do is they incite this. So what biochemical mediators, these 4 things here, they're going to cause a vascular response here. In that vascular response, what we're going to see is our vessels dilate, get closer to the skin, we get that red. And then we have increased permeability, because if you're thinking about like okay, think of like a blanket, and as you stretch that blanket, you know that like literally here, as you stretch the blanket, the things that make the blanket together get longer and they stretch. And if you think of it like a knitted blanket, you start seeing those really big holes in the blanket. And that's what this means, increased vascular permeability and leakage, because the gaps here get bigger. So these bad boys come in, right? They mediate, they go, let's make this vascular response take place. And then the vascular response takes place. We're going to get redness, and then we're going to get this huge gap here. And you have something take place called diapeditis. And diapeditis is just when your white blood cells, they come along, they stick right here, and they're like, and they squeeze their fat asses through these gaps that we've just made, okay? And the white blood cells are going to play a role later, but like right now, that's what we got. Like we got our biochemical mediators coming in, and then our vascular response taking place because these mediators said, hey, let's get this shit on the road, okay? Okay. So what is the purpose of this? Like, why do we have this, you know? Or really just inflammation, our second line in general. Well, we have this because we want to control our inflammatory process. We want to limit inflammation and further damage. So the things that are rushing into the site, like the white blood cells, are going to help in healing. They're going to end up helping them in activating our third line of defense. They're going to help making sure that further damage isn't brought. So like they're controlling the inflammatory process. So like if inflammation wasn't controlled in our body, instead of me getting stabbed and I just have a little bit of redness on my arm, I have redness all over my body. Cells are activated all over my body. And that's like a no-no. Okay. So you have two types of phases in your inflammation. You have the acute, and then you have a chronic. And most inflammation that you see is acute. So that's like just 8 to 10 days. So acute isn't just like 1 hour. It might begin immediately here, but it goes on for 8 to 10 days until what fucked us up isn't there anymore. So until the threat is eliminated. It is short, it is fast. But it isn't mediated by like your second and your third, it's not mediated by your T or your B cells. And that's partly why it's so fast, why it happens so quick. We don't have to go through this memory process of going back in time, figuring out which cell is the cell to put on and then creating our own response. And then we don't have to do anything complicated. We just involve the vascular response, okay? And so in our acute, you're going to see this vascular response mediated by the biochemicals, but you're also going to see something called the activation of plasma protein systems, okay? And there are 3 systems. So if we go down here, not only do we have inflammation, do we have the leakiness in our vessels taking place and white blood cells squeezing through, we have the complement system being activated, the clotting system, and the Kinnin system. And just to be a brief overview here, your clotting system is like, okay, I've been stabbed, right? And inflammation takes place. So things rush to the site. Clotting system is activated. And the reason why clotting system is activated, because if it's not, then our blood's just going to keep coming out. So we have to have something that stops my blood from leaking out. The Kinnin system takes place, which is like a mesh. So it's like, how do we close this hole when the hole's been, clotting doesn't do that. Clotting just stops your blood. But Kinnin is literally a Band-Aid that it puts on so that my hole that was formed isn't a hole anymore. And then your complement system is like where you start seeing like bacteria that get in being destroyed. So this system is like, okay, we're going to destroy some shit, but it's not specific. The clotting system is like, we're going to stop the bleeding. And the Kinnin system is like, we're going to close the hole. So that's also part of our second line of defense. It's also part of this inflammation here, okay? Okay. So all 3 of our systems have a proenzyme or something called like a sequentially activated cascade, which just means it's really fucking complicated. And enzymes activate other enzymes, which activates other enzymes, and it just continues onward, okay? So the complement system is, so it's what destroys like the pathogens. So once I get stabbed, if a pathogen gets in because I've been stabbed, the complement system is what's going to kill it. The kinnin system's not killing it. It's just making a mesh. The clotting system's just clotting the area up so that blood can't keep leaking out. So what kills things once my skin's been breached is the complement system. And there's 3 ways our complement system can be activated. So they're called pathways, but just think of it as 3 ways it can be activated, okay? The classical, the lectin, and the alternative. Your classical pathway is exactly what, so first off, when you're looking at this, it looks like this entire area here is the classical pathway. No, all of this is complement system. This is the classical pathway. So what is the complement system specifically? If we're just looking at, we want the complement system to activate. We want pathogens to be destroyed. This is what's happening. This, exit that, is what's happening. This is what's important here. C1 is activated, and I actually have it here, so we'll come over here. Okay. Get away. No. Okay, actually, why don't I just do that? Yeah. Okay, so the steps of the complement system are literally right here, okay? Something has to activate complement system, okay? And that's going to be the classical pathway, the lectin pathway, and the alternative pathway. But once it's activated, the complement system starts. The complement system is this. It's all that's orange that she's kind of highlighted here. So opsinin gets activated. Anaphylactoxins get activated. And then membrane complex gets activated. And anaphylactoxins are known as C5a. And once they're activated, you can think of your anaphylactic shock. Histamines are releasing. So stuff like that is being released. That's when you're seeing that anaphylactoid reactions, like mast cell is degranulating and your histamines are coming in and stuff like that. Opsinin is going to be tagging. So it literally looks like a tag. So C3b is activated in the complement pathway. Opsinin it's now called opsinin. And now we can tag the bacteria that we're like, we want this to be killed. And then the last thing that's activated in our complement pathway is membrane attack complex. And it's right here. It's like literally right here. And this is cell lysis. So think of the Defins that like had the swords and were like poking holes and shit. This is doing the same thing. It's literally basically a defensin in a way. It is activated and it just starts poking and stabbing the shit out of this bacteria. So a bacteria comes in. Somehow our complement system is activated. Anaphylactoxins, C5a is activated so we can release histamine. Membrane attack complex, otherwise known as C5b, is activated so we can start lysing these cells. And then C3b, opsinin, is activated so we can tag the bacteria. Okay, so if we want to start this system, the complement system, we have to turn it on. Turn it on in 3 ways: classical, lectin, or alternative. Classical is like, it's like, I don't know. So it's like you're shopping at a grocery store. You go to start the process of getting your groceries in the cart. But before they do that, they're like, hey, you have to pay me first. You have to give me something. So we have to give them an antibody. Okay, so an antibody binds to the bacteria and makes a complex. So if we want to start complement system, we have to do it the classical way first. And we give them $1. We're like, okay, here, we pay for our groceries first, which is, the $1, the fucking awesome thing, which is just an antibody complex. Now complement can start. And then that's exactly that's the classical pathway. That's all you need to know. You're giving the dollar. You're giving the antibody antigen complex to start complement. Okay. Lectin is, okay, well, this is $1. I can pay you with $21, or I can pay you with just a $20 bill. So it's like another way we can get our groceries, or we can start all of this. Opsinin, anaphylactoxins being activated, and cell lysis being activated. So it's specifically known as MBL. And this M stands for mannose binding lactin. It's not an antibody that we're giving them. That's the classical pathway. Almost always when you're thinking of like complement, you're thinking of an antibody. That's the classical. Lectin is mannose. So mannose is sugar. So it's like it's recognizing the sugar on the bacteria is not one of the human sugars that's supposed to be there. So it's like, bro, what's up with your sugar? But it's still $20. It's still it's $20. It's just a $20 bill. So this complement system is still going to be activated. And then alternative pathway is like, okay, bro, you need to pay for your groceries, but you don't have a $1 bill. You don't have a $20 bill. And then the old man behind it's like, here, miss, I have some change for you. So you start paying in like nickels and fucking dimes and shit. You don't have dollars to pay, but you can still start this process. It's just alternative. It's like an alternate. You don't have dollars. You have coins instead. So like still the same end result. The only issue is like somebody's coming, like here, it's like product of infectious microorganisms bind C3b. So this is like somebody's taking our fucking dollars from us, bro. Like we don't have any dollars, so you gotta like jiggle around and look for quarters and shit. So our C3b here is bound, so we can't. This takes place when like we don't have antibodies, we don't have mannose binding lectin or whatever it's called, but because something's taken that away from us. So like bacteria have this awesome thing called, like immunity that they develop over time. And it's like, well, once it becomes immune to both of those, or it fucks something up in this pathway, it's like, haha, I'm going to come. And what it actually does is like it fucks up C3b here. It's like, fuck you. I'm not going to. So now we don't even have that. What the fuck? Haha. Instead, we're just going to pay for it with nickels and dimes. That works just as well. Boom, the pathway started. Now we can have complement. Now we can have, just like before, our opsinins reactivated, our anaphylactoxins are reactivated, and our cell membrane is reactivated. So commonalities with the complement system, all three of these start paths, these alternate lectin and classical paths, they all have to have C5 activation. So if you look here, C5 activation, all of them do that. And remember, that's like the poking, stabbing thing. Hold on! All three of them are going to end with anaphylactotoxic activity, which is like histamines being released. Leukocyte chemotaxis, which is like stabbing the cell. Opsonization, which is like our tagging. And then cell lysis is the end product. We've had it dead. Damn it,